All right, now let's talk about definite intervals. First thing I want you to do is write down this definition. If f is defined on a closed interval, right, and that interval is a to b, all right, then the limit as the partition goes to 0 of the summation of I goes from 1 to n if f, ci, x of I exists. So if it's defined and it exists, then f is integrable on the same limit, and that limit is denoted by the integral from a to b of f of x dx. This is called a definite integral from a to b, and a is the lower limit and b is the upper limit. Usually a is less than b, but it's possible for a to equal b or a to be greater than b. We'll discuss what happens when we have that situation. Now, there's one word I want you to write right after the definition of a definite interval, and that is number. This is always going to give you a number. It might not be a pretty number, but it's still a number. When we get to indefinite intervals, those are always going to be functions. Now, continuity implies integrability. So if the function is continuous on an interval, then it's also integrable. You notice we say it is. This is an existence statement. It doesn't tell us exactly how to find it. So how would we find a definite interval of, say, y equals 2x on the interval -2 to 1? All right. Well, first of all, let's define a regular delta x of I, and this is going to be the same for all of them, as b minus a divided by n. So this becomes b, which is 1, minus -2 divided by n, or 3 over n. Now, if we are to define our c sub I as a right endpoint for each subinterval, then c sub I is going to be a plus I delta x, which is a, which is -2, plus 3I over n. All right, then I'm just plugging things in here now. So my definite interval from -2 to 1 of 2x dx is equal to the limit as the partition goes to 0 of the summation I equals 1 to n FCI delta x of I. Now plugging what I know in, I know this is the same thing as a limit as n goes to infinity of the summation I equals 1 to n of FCI delta x, because they're all the same. So now let's plug in what we know. This is the limit as n goes to infinity of the summation from I equals 1 to n. Now FCI is 2 times x, so, or CI, which is -2 plus 3I over n, times delta x of I, which is 3 over n. All right, so this is the limit as n goes to infinity of the summation I equals 1 to n. Now I'm going to factor out this 2, 3, n here of 6 over n, and I'm going to put it out here. Now this is -2 plus 3I over n. All right, we know how to do our sums. So this is a limit as n approaches infinity of 6 over n times, let's see, this is -2n plus 3 over n times the summation of I, which is n plus 1 times n divided by 2. It doesn't matter whether you put that forward or backwards, I just learned it that way. So this, becomes the limit as n goes to infinity, and I'm going to multiply this mess out, and that's going to give me -12 plus 9 plus 9 over n. All right, now it goes to 0. So your answer is -3. Now, are you okay with this being negative? I am. Because this area right here is going to be negative, while this area right here is going to be positive. And it's very clear that this area is greater than that area. All right, pause the video. See if you can do this, evaluating the following as a limit. When you're done, come back. Now, let's define the area, the integral of an area, thus define the integral as the area of a region. Okay, if f is continuous and non-negative on a closed interval, a to b, the area is equal to the integral from a to b of f of x dx. Now, I pretty much already alluded to this. Let's look at this situation right here. F of x is 2x squared minus 2x minus x squared. It's a parabola. If I had some way to find the area of a parabola, then I could just go, oh, well, this area is. Now, we don't have a definite way to do this, but it doesn't matter, even if you can't integrate it. All right, we could go back and do this as from the definition and take the limit. I don't want to do that right now. Let's do some where we don't have to do quite so much work. Let's look at the area of a circle. All right, if f of x is the square root of x, 9 minus x squared, then the integral from -3 to 3 is just the area of this circle. Now, what's the area of a circle? Area of a circle is pi r squared. Now, we only have half the circle. So, this becomes the area of a half circle. Yes, I want you to write this. So it's 1/2 pi r squared, and in this case r is 3, so it's 1/2 pi times 3 squared. Alright, so this is 9 pi over 2. You can write this as 4.5 pi. You can give me a definite number, that's fine. This is perfectly okay with me. What if we have this situation right here, the area of a rectangle, from 1 to 3? So it's this area right here. Now we can do some fancy calculus. We will later. But what's the area of a rectangle? Okay, this is the area. And I'm going to write rectangle. All right, base is 2, height is 3. So you have a rectangle is base times height. So this is 2 times 3, or 6. Move on. See how easy this is? What if we have a trapezoid? Okay, same thing. You're going to have to find those 2 points for this one. If we want to find the area of a trapezoid, the area underneath 2x plus 1 is what? 1/2. We have to write area of trapezoid. So that's 1/2 times the base times h1 plus h2. Now for this one, you do have to find what h1 and h2 are. h1 is 2 times 1 plus 1, which is 3. h2 is 2 times 3 plus 1, which is 7. Pretty close to what I see there. So this area is 1/2. The base is 2 times 3 plus 7. So this is 10. Now, try these. When you're done, turn off the tape, finish your homework.